This project aims to predict whether a loan applicant is likely to default based on the various financial and credit-related features. By leveraging the multiple machine learning models, we seek to enhance lending decisions and provide interpretability through the model explanations. In the data pre-positioning stage, we just remove the duplicates and handle the missing values. And also we deal with the skewness. We use the smooth to decrease the imbalance between the default and the non-default cases. And then for the model selection and the evaluation, we first use random forest, and here is a code, and then we use a PyCaret. Here is a outcome to compare the multiple classification models. After the comparisons, LDA emerged as the best performing model, demonstrating the strong generalization capabilities on both training and the test sets. So for the model interpretation is the central focus of this analysis to explore how different features influence the model's predictions. So First, we have the permutation importance analysis, highlights that the earliest credit line and the loan amount are the most critical features influencing default risk. Borrowers with a longer credit history and smaller loan amounts tend to have a lower default probabilities. And then we have the Sheff value further confirms these findings, showing that the high loan amount values increase default risk, while the low early credit line values also correlated with the higher risk. This reflects the idea that the short credit history and the large loans are major risk factors. And then we have the KDE distribution of the predicted probability suggests that the most values fall between 0.3 and 0.6, indicating a well-balanced model. However, some high-risk cases suggest that the adjusting the classification threshold may improve precision. And then we have the PDP graphs reviews that the higher interest rate leads to increased default probability, which aligns with the leading risk strategy. Meanwhile, the different title values, which is loan purpose, show varying default risk, suggesting that the lenders should assess risk based on the loan type. And then we have the decision trees surrogate model provides an interpretable breakdown of the LDA model, confirming that the earliest credit line and loan amount and also the vehicle range loan, which is the credit score, are the main decision factors. This visualization helps a financial analyst understand how the model makes the predictions, enhancing the transparency in the credit risk assessment.
Here's Wenze, and there's a second model. The data set is sampled into 1,000 observations, ensuring randomness. And SMOD is used to generate the synthetic samples, and RFE select the top 5 features based on the attributes classifier, shows that these 5 are key features. PCA also used to reduce the dimensionally of the data set with the perceiving variance. And the plot shows that the first PC1 explains almost the variance and indicates that the data set has high redundancy, and most of the importance is captured in a single component. Attributes training, and here is attribute training and report. The accuracy is 0.775 with high precious 0.83 and recall 0.91, but the performance of the class 1 is weaker, which requires only 0.21, means that may actual defaulters are missed. And next is learning curve. The training accuracy is consistently high, and the cross-validation score increased with the training size but remain lower than the training accuracy. The gap between the curves indicates that the potential overfitting. And next is attributes feature importance. Use a building function to show the building function plot importance to show the importance of the feature based on the models learned with. The permutation importance confirms that the interest rate is most important, followed by the open account, employment title, and the revolve balance. And next is the extendability methods analysis. The first is the SHAP. Here, the plot shows that the magnitude and the direction of the features contributions and the plot visualize features impact. With high interest rate, increase the default probability. With high title values, negatively impacted. Fourth plot explain how the individual's features contribute to the single predictions and explain that the interest rate contributes the increasing most the prediction score because of the shape value is positive and the color is red and title low amount decreases. You can see here. And the next part is permutation importance. It also confirms that the interest rate is the most important. And the next is a partial dependence plot. It illustrates the effect of the single features on the model's prediction while averaging out of the effects of the other features. Interest rate PDP shows a strong positive relationship, indicating that as the interest rate increase, the probability of the default also increase. And annual income PDP exhibits an fluctuating trend, suggesting that there is no linear relationship between income and default risk. Higher incomes may correlate with lower default probability, but with variability. And the last part is LIME. It uses instance features and trains in the interpret models to approximate to our original black box model local features like interest rate higher than 31%, open account less than 3.2, and date higher than 6.73 increase the probability of the default. That's the orange bars, while the title here and the earliest credit line higher than 400 increases that is blue bars, and the direction probability of the indicates that the instance classified as default with 57% confidence. That's it. Thank you.